The James Webb Space Telescope has discovered something truly extraordinary: beams of light that appear to radiate from the heart of a city, shining from a location for light years away. This discovery has sparked renewed interest in the potential existence of extraterrestrial life. The telescope directed its focus towards Proxima Centauri and the closest exoplanet to ours, Proxima Centauri b, and observed odd flashes of brilliant light. Could these signals be signs of an alien civilization? Keep an eye out for more developments. For a long time, both scientists and the general public have been captivated by the idea that there is life beyond Earth. Any evidence hinting at the presence of extraterrestrial life has been met with a lot of enthusiasm, but a pivotal moment came when the James Webb Space Telescope was launched. It presented clear evidence suggesting the existence of life in some part of the cosmos. While scanning the depths of space, this powerful telescope discovered something extraordinary on a distant exoplanet. It detected lights similar to those from extraterrestrial cities, igniting the possibility that an alien metropolis might exist on that distant planet. This concept has resulted in significant enthusiasm and interest in the scientific community, as it could be the breakthrough they had been hoping for. It hints at the presence of intelligent beings operating civilizations in ways we are just beginning to investigate. Looking at these city-like lights from a remarkable distance of light years away, NASA engineers are astonished and wonder just how long they might have been visible in space, awaiting our technology to advance to the point where we could detect them. David Kipping, an astronomer at Columbia University, has described the planet where these lights were discovered as particularly intricate. Unlike most rocky planets that absorb sunlight and emit energy as infrared radiation, this exoplanet behaves differently due to its unique relationship with its host star, Proxima Centauri. This discovery, made by the James Webb Space Telescope, highlights the crucial function of the telescope. Its ability to capture infrared wavelengths was essential for spotting the unusual behavior of Proxima Centauri b, which is important for comprehending the planet's atmospheric conditions. Scientists are planning to continue using the telescope to study the atmosphere of this planet in more detail, with hopes of investigating the possibility of habitability. The James Webb Space Telescope is particularly sensitive to infrared light, enabling it to observe what happens on Proxima Centauri b even during the night. Many telescopes struggle to detect faint light in the vast darkness of space, but the Webb telescope excels at picking up even the faintest glimmers. This makes it an ideal tool to confirm if the alleged city lights on Proxima Centauri b's dark side are indeed real. The telescope is able to find artificial light in space, provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic interaction with its star, which heavily influences its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the world revolves around the star, it goes through cycles of day and night. The planet has the same problems as Earth: scorching heat during the day and cooler nighttime temperatures. The range of temperatures on Proxima Centauri b is vast, primarily due to its composition. For example, if the planet lacks an atmosphere, the temperature difference would be extremely wide between day and night: frigid on one side, hot on the other. This dramatic change in temperature is a key area of interest for astronomers, as it provides useful information about Proxima Centauri b's atmospheric makeup. The James Webb Space Telescope, with its aptitude for the infrared imaging spectrum, can effectively examine the planet's thermal emissions, offering insights into its climate properties. Interestingly, the orbit of the James Webb Space Telescope around Earth coincides with the orbital period of Proxima Centauri b, enabling scientists to make detailed observations of its daylight cycles every 11 point-to-Earth days. If there is an atmosphere on Proxima Centauri b, the next step will be to analyze its chemical composition to determine if it could support life. Detecting oxygen, water vapor, and methane would suggest the planet's potential to harbor life. This would involve studying the light passing through the planet's atmosphere, a complex process. While the James Webb Space Telescope is excellent for characterizing planetary atmospheres, it is primarily designed for other tasks. Its expertise lies in analyzing carbon dioxide, water vapor, and methane concentrations. However, it's less adept at detecting free oxygen, a crucial sign of life. Nonetheless, the telescope can search for other key indicators, like ozone, which signals a healthy atmosphere. As scientists examine the data collected by the James Webb Space Telescope, the hunt for distant worlds continues, bringing us ever closer to answering whether or not we are the only ones in the universe. It is essential to note that the James Webb Space Telescope can only observe a limited number of exoplanets closest to Earth. For more detailed studies of planetary atmospheres, astronomers will use terrestrial observatories like the Extremely Large Telescope ELT, which is set to begin operations in 2028. The ELT is designed to offer a deeper look at the atmospheric structures of far-off exoplanets, providing clearer and more detailed data on their potential to support life. Scientists are excited about awaiting the launch of future space telescopes like the ELT. In the meantime, the James Webb Space Telescope remains an invaluable tool. The Webb Telescope continues to offer critical information that may alter our perception of the world beyond our solar system. Researchers have ambitious plans for future space telescopes. They aim to develop technologies that reduce star-light interference, allowing for better observation of the planets around them, similar to blocking the sun with your hand to see more clearly. These future telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess whether they might support life. However, this task is far from simple. Stars shine so brightly, often vastly outshining their surrounding planets. This radiance makes it difficult to detect the faint light that planets reflect, which is essential for studying their characteristics. To address this challenge, scientists are working on several innovative techniques. One method involves the use of coronagraphs. These devices are placed inside telescopes to block out star light while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly decrease the star's brightness, making it easier to detect the dim light from exoplanets. Another promising approach is the Starshade, a massive, flower-shaped spacecraft that will fly in formation with a telescope positioned tens of thousands of kilometers away from the telescope. The Starshade blocks starlight before it even enters the telescope, allowing only light from exoplanets to reach the instruments. This technique could be particularly effective in observing planets within the habitable zone of their stars, where liquid water and possibly life could exist. However, these advanced technologies require extraordinary precision. For example, the alignment of a starshade must be perfect to fractions of a millimeter over vast distances. Moreover, these innovations must overcome the limitations posed by missions in space, including the requirement for miniaturization, energy efficiency, and the ability to withstand the harsh conditions in space. Despite these obstacles, the potential rewards are enormous. Effectively observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life, such as water vapor, methane, or oxygen in specific ratios. These molecules could indicate biological processes, suggesting the possibility of life beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes could be equipped with advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's movements, resulting in sharper images with star light-blocking technologies. These improvements could allow scientists not only to find exoplanets, but also to map their surfaces and study their climates. The development of next-generation space telescopes is a significant leap forward in our quest to answer one of humanity's most profound questions: are we alone in the universe? By enhancing our ability to observe these far-off planets, we are coming closer to finding out if life exists beyond Earth, potentially transforming our understanding of our place in the cosmos. The future of space exploration and the search for life on other planets is advancing at an unprecedented rate. As scientists and astronomers delve deeper into the mysteries of distant exoplanets, the James Webb Space Telescope heralds a new era in cosmic discovery. The data it gathers is helping astronomers make groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. With each additional piece of information, we edge closer to answering the ultimate question: is there life beyond our planet? The discovery of Proxima Centauri IB is just the beginning of what could become a major turning point in how we study the existence of life on other planets. Proxima Centauri IB, orbiting the star closest to our solar system, has been a focus of intense study for many years. However, until now, finding concrete evidence of life such as artificial light or signs of civilization has eluded scientists. The fact that such light has been detected only by the Webb telescope enhances the hope that one day we may communicate with other intelligent life in the universe. This kind of finding fuels both scientific curiosity and public imagination, inspiring new generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it is not only looking for artificial lights, but also focusing on planetary atmospheres and their chemical compositions, as well as the ways in which these factors could support life. The search for biosignatures, like methane or carbon dioxide in the right concentrations, is vital for understanding whether these planets have the conditions necessary for life. The Webb telescope has the ability to analyze these atmospheric components unlike any other telescope before it, shedding light on the potential of distant worlds to support life similar to Earth. One of the most fascinating aspects of Proxima Centauri IB is its location within the habitable zone of its star, where conditions might be suitable for liquid water to exist on its surface. The habitable zone is the region around a star where temperatures are just right, neither too hot nor too cold for liquid water to form, which is considered a critical factor in determining whether a planet could harbor life. Water is essential for life as we know it, making the discovery of a habitable exoplanet within a star's habitable zone a key target for future missions. In addition to finding life-supporting planets, future space telescopes will also focus on the complex relationship between exoplanets and their stars. Some planets, like Proxima Centauri IB, are tidally locked, meaning one side always faces the star while the other remains in darkness. This can create extreme temperature differences between the two sides of the planet, affecting its climate and potential to sustain life. Understanding these conditions is crucial for astronomers in evaluating the likelihood of habitable environments on exoplanets. The development of technologies that can block out bright starlight is another important step forward in space exploration. Without the ability to block starlight, it would be virtually impossible to observe the faint glimmers of light from distant planets. Coronagraph and starshade technologies are prime examples of how scientists are overcoming these challenges by blocking the overwhelming brightness of a star. These tools will enable telescopes to detect the faint light reflected by planets, which could reveal crucial details about their surfaces, climates, and potential for life. Another exciting development in this field is the concept of direct imaging of exoplanets. With the support of advanced adaptive optics and starlight blocking technologies, astronomers hope to capture high-resolution images of planets as they orbit their stars. These images would not only provide more detailed information about a planet's composition and atmosphere, but could also offer a more in-depth look at surface features such as oceans, weather patterns, or continents. This type of imaging would represent a giant leap in our ability to study exoplanets and make informed conclusions about their potential to support life. As we continue to explore the universe and seek clarification regarding the existence of life beyond Earth, the role of future James Webb Space Telescope missions will be indispensable. The telescope's ability to detect faint signals from distant planets, analyze their atmospheres, and examine their potential habitability is transforming our understanding of the cosmos. With advancements in technology and a growing collection of studies, we are on the brink of making discoveries that could alter our understanding of life in the universe.